Hello, good evening, everyone. Can you hear me?
Yes, ma'am.
Hello. Yeah.
Yes, ma'am.
Okay. Screen is okay. Visible.
Yeah, it's pretty good.
Okay. So today we will discuss week 9 topics. So the first topic here is random variable. Have you guys watched the lectures?
Only the first one, ma'am.
Oh, fine. Okay. Random variable. Till now, what we have seen? We have seen we perform some random experiment, and then we what let's say some random experiment is performed, and then we find the sample space out of it, like, right? Random experiment we perform, and then after that we find what is the sample space, what is the possible outcomes we find. Okay, that is we call sample space. And then we were finding the probability of particular event, right? Till now, these things we were doing, right?
Yes, ma'am.
Yeah. Now we will do some extra things. See, let's say your sample space is, let's say omega is your sample space where some events are there. Let's say your random experiment is tossing a coin, okay? Tossing a coin. So what will be your omega in that case? Yes.
HH and
Why? HH. Tossing a coin means a single
H
coin is
comma.
tossed.
Yes.
Okay. So your simple space will be H and T. Now, we have defined any function over this omega till now? Do you remember what we were doing? We were just calculating what is the probability of H, what is the probability of T. We have calculated this kind of thing, right? But
Yes, ma'am.
now we will define a function on this sample space. Okay. You guys have learned this function in your mathematics class, right? Is it okay?
Which function, ma'am?
What is function? You know, like that, okay?
Yes, ma'am. Yes.
Okay. So let's say capital X is one of the function which I will define from your sample space omega to a real number R. Okay.
Okay.
So here we are actually, this is what we say, this is abstract form. This capital X is a function which is mapping a event with your a real number R. Okay. How it will relate, I will say you. Now, once I have written this is not function. Okay. I have to define something for X. So I am saying X is number of heads. Okay. So can you tell me how many what values my X can take?
1,
1 and
0. 1, 0.
yeah, 1 and 0. When it will take 1?
When there is a head.
When say event is equal to H and event is equal to T. Okay.
Yes.
Right? So
Yes.
we will do this kind of thing in this week. Okay. So let's yes.
Ma'am, can you explain balance sheet?
Sorry.
I just joined. Can you explain balance?
What was the time, by the way? Okay, we will explain in the next example. Okay. See, we will define here we the random see. whatever we are doing here is we will have a sample space. We will define a function which will map your events of sample space to a real number R. Okay. And let's say this is my capital X. You might have learned in mathematics that generally we denote function in small letters, right? But here, this kind of function, what I have defined, this X, is known as random variable. Okay. So what is random variable? It's a function that connects your sample space with real number. Okay, this X is known as random variable. Okay, is it fine till now? So
Yes, ma'am.
it's a function where actually random variable is a function which connects your omega, omega means sample space, and numbers. That means real numbers. Okay, that you all know that there are let's say we will have an example. Let's throw two die. Okay, two dice are thrown. Then what will happen? Your sample space will be
1, 1, 1, 2, 1, 3.
Yeah, this all everyone know, right? 1,
Yes.
6 till we get
6, 6.
6, 6. How many entries are there? Some 36 elements are there, right?
Yes.
Okay. So the thing is, the difference, this is actually the new topic, whatever you have learned till now, because till now we were just calculating the probability of event. We were just defining, let's say the sum of numbers is 3, then find the probability that of an event where sum of the number is 3, right? You are calculating this kind of thing. Okay. Now I am saying, okay, let x or let any x, yeah, x is equal to sum of numbers, right? Okay, sum of number on die when you throw two die. Okay, right. So this is something new. Till now you haven't done any kind of thing, right? This kind of thing. Now this x I have defined a number or a variable which gives me sum of numbers on dice. When you throw die, let's say your die is landing on 1, 2, then what will be the value of your x? Then x will be 3, right? Are you getting my point?
Yeah.
Okay. So if you have this event, that is we have thrown two dice, then can you give me the range of this x? What the values x can take? Like what are the possibilities for x?
2, 3,
2 to 12.
5, 6.
2 to
2 to
12.
2 to 12,
12.
right?
12. Yes.
Yeah, 2 to 12. How did you get to know? You just have summed these numbers. Okay. So now the question will be if someone asks you or find the probability of capital X is equal to 3, can you calculate it for me? Like how will you do that? Can you find when this X is equal to 3 can happen?
Yes, ma'am. 1, 2, 1.
So X is equal to 3 is possible when your event E will be 1, 2 and 2, 1, right? Anything else possibility? No, no.
No, ma'am.
Okay. Then how will you calculate probability of X is equal to 3? This will be
2 by 36.
2 by 36. Okay.
Yes, ma'am.
Okay. So now the question will be like that. You there will be one defined random variable will be like that. This x is the sum of number on dice, and they will ask you probability of find the probability that x is equal to 3. Okay.
Okay.
Do you understand this? Okay. So similarly on the same sample, see this omega is one sample space. Okay, in this omega I can define one more variable also, like one more random variable. Let's say y is let's say whenever you throw a 2 die, I will pick the larger number, or you can say maximum of a comma b. Okay, maximum of a comma b. Then can you guess what will be the values y can take? This a comma b is what, you know? This a is a, or like a first die is output, and b is the second die. Okay.
What if A and B both are equal? Like 1, 1?
Yes,
Then
ma'am.
can you tell me what is the maximum of 1 comma 1? It's 1 only. Okay. Will you guys try? What should what these values y can
Then it
take?
will be 1 to 6.
Huh? Sorry.
1 to 6, ma'am.
1 to 6, right?
Yes.
Your y can take values 1, 2, up to 6 it can take. Like
Yes.
this will be the range space of y. Okay.
Ma'am, do
Yeah.
we have to find the range of y for every time
No,
whenever
no,
there
no,
is a
no.
question?
This is just I'm introducing the topic. That's why I'm like talking to asking you to calculate all this. Otherwise, this is not it. Say if someone asks you your y is this function, you understood, okay, y is equal to maximum of ab, and I ask you what is the probability that y is taking value 8.
Zero?
Yes, that's why
0,
the
ma'am.
range is important. If you know the range, this answer you will come to 0 in fraction of seconds, right?
Yes,
Ma'am,
ma'am.
could you please repeat that y is equal to max a b from that point?
Yeah. Max of AB means whatever your this max of A comma B. This A comma B is my like value when 2 dice are thrown. Okay, this is the value. This is the number on which first die is landing, and this is the number on which second die is landing. Okay, so if you get the number 2 comma 3, so y will be, what will be the y? Y will be the maximum of 2 comma 3, which is equal to 3. Okay.
Yes, ma'am.
Do you had any other doubt regarding that?
No, ma'am.
Okay. So did you guys find the difference between what we were used to do and what now we are going to do? Let me ask you one question. Can you find probability y is equal to 2? You know y is same. Okay, y is my maximum of whatever the two dice are landing on. Okay, this is y, and now the task is to calculate what is the probability of y is equal to 2.
V by
3 by
36
36.
Sorry,
2 by 36.
by 36.
3.
t by 36.
Yeah.
Yes, ma'am.
How did you come to this answer?
2, 2, 1, 2, and 2, 1.
Ma'am,
Are
events
these
are
the
1, comma
only
2. Yes.
yes, and 1 comma 2? Are these the only possibilities?
Yes,
Yes,
ma'am.
ma'am.
Just consider the question again. Whatever the your sorry, I will go to this sample space. Whatever you will throw, when maximum is 2, that you have to find. Okay, you want y is equal to 2 means what? your maximum of A comma B should be equal to 2, right? So why not will come?
Yes.
So yes. So we have to consider all the, if we are fixing A as a 2, then all the values consider which are less than 2. So there are only 3 possibilities. So it is 3 by 36. Okay. Anyone has doubt on this topic? Okay.
No.
Then there is something called probability mass function. What is probability mass function? If there is a random experiment is done and omega is a sample space and x is your random variable. First, let me describe one type of random variables. Okay, x is random variable and x is discrete also. Just a minute, I'm explaining what is discrete. Okay. Till now, you may have seen some function. Let's say there is some function f of x is equal to e power x, and there is one function called. Okay, we do not need to go to functions. Let it be. Yeah. Let's say there is a class of some 100 students. Okay. Class of 100 students. Now, x is a random variable which is measuring height of the student. Height of student. Okay. So what can be the height? Can you if we are measuring in feet, then it might be 5.1, 5.2, 4.1, 4.2, right? All these are possibilities
Yes,
and all
ma'am.
this. Okay. So let's say that's the class 7th above student are there. Then we will just, on an average, we are considering that height will be lying between 4.5 to some 5.5. Okay. In this open interval or closed interval. So this x can take all the values lying between this interval, right?
Yes, ma'am.
So these type of values, and do you know countability of this set? Like how many numbers are between 4.5 and 5.5?
Infinite, ma'am.
Yes, infinite, but
Yes.
it's uncountable.
Yeah, uncountable.
Okay. So whenever there is a random variable defined such that your range of x, yeah, that means x is taking uncountable values, uncountable numbers, then such a random variable is called as continuous random variable. Okay. Random variable. Okay. Are you getting my point? Whenever you have defined the random variable such that your random variable can take uncountable number of values, then the random variable is called as continuous random variable. Taking uncountable values means its range is uncountable, right? And
Ma'am,
see the up. Yes.
I have a question that if
Yeah.
x is a random variable is a function, then these are the domains we can say, means the value which x can take.
Domain is your sample space. You can take, domain is what? On which you define the function, right?
Yes, ma'am.
The set on which you can define the function. So here your domain is this 100 students, and you will pick any student and you will measure the height of that student. Okay. So domain has nothing to do here. Yeah. What was your question, by the way? Domain is sample space here.
Okay. You can define any function.
We are like what we are doing in random variable, we are assigning a number to sample to, let's say, event of sample space. Okay. When we are talking about the
You can
random
assign
variable,
a number to events of sample space.
events, yeah.
Yeah,
Okay.
events. Yes, ma'am.
So just look out this example, this 100 student, and we are measuring the height of student. So for each student, we have one parameter. We have decided one number for that student, that is height. Okay. So a height is taking some uncountable number of values. Like a height can take uncountable numbers. So this x, the range of x will be uncountable, and so your x is continuous random variable. The same thing when it comes to discrete. What is discrete then? The discrete is just opposite to that. When your x, when or x or y, that means your random variable can take at the most countable values. Okay, where it is?
Or integral value.
When a random variable can take at the most countable values. Then it is a discrete random variable. Okay. Are you able to distinguish between discrete random variable and continuous random variable?
Yes, ma'am.
Okay. We had one example that event is the experiment is, we have thrown 2 dice. Okay. Throw two die. In that experiment, I have defined one x as sum of the numbers. Okay. Sum of number. And one random variable I have defined maximum of a comma b. So what x is, like x and y both are random variable.
Yes, ma'am.
Are x is discrete or continuous, y discrete or continuous?
Both are discrete, ma'am.
Yes,
Yes.
ma'am.
Both are discrete because both are taking finite values only, right?
Yes, ma'am.
Both are discrete. This is also discrete.
But if we say Z, there is a random variable,
Okay.
division of A by B, then it is discrete or continuous?
Yes. Then what a by b can take? What is your
Can
a
take
is?
continuous.
Sorry.
Can take fractional values, ma'am. So it can
Can
be
take
continuous.
fractional values, but how many? Like, are there infinite choices it have? Like, because for
Actually,
A you have 6 choices, for B you have 6 choices.
then still it will be accountable.
Yeah, because can you make the set what the possible outcomes you can get when you calculate the A by B? So you have to just
Yes, ma'am.
calculate 1 by 2, 1 by 3, like this 36 calculation you have to do. That's all, right? You
Yes,
can't
ma'am.
get any extra number out of this 36. Even I will say the number will be less than 36 only if you give A by B. because there are six elements are like a comma a. 1 comma 1 will give you 1, 2 comma 2 will you give 1, right? And all this.
Yes, ma'am.
So this is countable only. So then also this is discrete. Okay. So by the way,
Okay.
in this week 9, we are discussing only discrete random variables. Okay.
Okay.
So first, if you are clear with this, then I will go to probability mass function. Anyone has doubt on this topic, then please ask.
No, ma'am.
Okay.
No.
Then it comes to
Okay. Ma'am, will you take doubt from assignment as well?
let's see what the time remains. Are you asking
Okay,
on
The
the
ma'am.
end of
week 9 assignment?
Yes, ma'am.
For week 9 assignment, you have class on Sunday.
Okay.
Today, I don't think so. Do you guys have solved the assignments?
No, ma'am. I have not still solved.
Yeah, because it's too early, na?
Yes, ma'am.
Okay, ma'am.
For assignment and activity question, you have a class on, I don't know, Saturday or Sunday. Most probably Sunday only. Probability.
Oh, but ma'am, my doubt is from only probability question.
Okay.
But no worry, I will ask at the end of the session.
Okay, yeah. Sure. Probability mass function. See, this is nothing but the some probability mass function also we have calculated in above, when we are checking the probability of x is equal to 3 and x is equal to 3, x is equal to 4 and all these things. What is probability mass function? It is nothing but the probability of whatever your x is. Let's say x is a discrete random variable, okay? X is a discrete random variable, and x is taking some values, let's say x1, x2, xn. Then if your x is taking these values, you can calculate probability x is equal to x1, probability of x is equal to x2. All this probability you can calculate, right? These
Yes, ma'am.
are when written in one format, which format is like this. You will form x, and I will say it px of xi. This is x1, probability of x is equal to x1. x2, probability of capital X is equal to x2. When you calculate the probability of each and every output or range value, it is called as probability mass function. Okay, there are some properties that probability mass function follows, which you even know, but not in the context of probability mass function. I will tell you. Okay. Do you understand this topic? Like, for example, if I am throwing a two die, and my random variable is sum of the numbers, then my x1, x2, xn will be like 2 to 12. All will be there, right? 2, 3, 4, 5. This x you only told me 2, 3 till 12. All will be my this x size. And if I calculate I can calculate the probability of x is equal to 2, probability x is equal to 3, and I put in this format, then it's a probability mass function. So this kind of arrangement is PMF. Yeah, one more thing, we denote maximum time it as a PMF, probability mass function. Okay. See, there are some rules for probability mass function. What? Two rules actually. First, your probability of x is equal to xi will be always greater or equal to 0. Okay, it can't take negative values. And the second thing is summation I is equal to 1 to n or infinity, because countable numbers are there, of probability x is equal to xi. This is equal to 1 always. Okay. So whenever there is if the question is like you have given with these values and they ask you, is this a PMF of given random variable? Then you have to check the values of these probability x is equal to 1, x is equal to 2, and x is equal to xn. Are they all greater or equal to 0? First condition done. Okay. Then move to second. The sum, take the sum of all the numbers. Is it equal to 1? If it is equal to 1, then yes, the given table is the PMF of your random variable. Okay.
And
Yes.
probability mass distribution and probability mass functions are same.
Probability mass distribution here, like yes.
Means that is also the same. We can say.
Yeah.
Yeah.
Function distribution. Like as this is the starting point, we are taking small steps only. Okay.
Okay.
So just first, like, is it okay? Like this definition was okay with everyone?
Yes, ma'am.
Okay.
Yes.
So till now, what examples we have taken? Let's say 3 coins are tossed. 3 coins are tossed. And x is a random variable, like number of heads, a number of tails. Okay. Then what can be the x values, like possible values of x? Anyone? We will
0.
calculate for this random variable. We will check all the thing we have done till now. Okay, we will calculate is it discrete or not, or what is the PMF and all this things. Yes. So first
Okay.
we will x is a random variable. What the possible values it can take?
0, 1, 2, 3.
Yeah. When 0 will be there? 1. I am writing it like this. So yeah. When 0 will be there?
When all are heads.
Yeah. When the
Yeah.
event is H. And when when 1?
2 ahead and 1 tail.
HT.
Sorry. HHT.
HTH.
Yeah. HTH. Anything? No.
No.
Okay. Then 2. When it will be DTH.
EHT.
Yes.
And 3 when?
TTT.
Okay. So these are the
Yes.
all values your x can take. And note one thing, whenever we represent a random variable, this letter is capital letter. Okay. Okay. These are the values x can take. So how to calculate now PMF? I wrote the things here because we have to calculate PMF also. See, PMF can be written as Px is equal to 1. Okay. Some people write it like maximum. This is the basic notation. Someone can write it as P capital X of 1. This is what your random variable. Okay. This is what the number you are requiring. Okay. So if
Yes,
someone defines the y is equal to, let's say, number of heads, and x is the number of tails, then x and y both are random variables. Okay. So the question may be asked like calculate the py of 3. So you should not be get confused that what is this. That's why I'm telling this is notation only. Okay. or this is equal to probability of y is equal to 3. Fine. Okay. So yeah, what is our px of 1 here?
3 by 36, ma'am.
Yeah, px of 1, 3 by 36. Why 36?
216.
8. It's 8. Sorry. 3 by
Yeah.
8.
Yeah, sorry, 8.
Yeah, this will be 2 by 8 or 3 by 8.
3 by 8.
Yeah, 3 by 8. Okay. Similarly, or p of x is equal to 0 will be
1 by 8.
1 by 8. Probability of x is equal to 2 is
3 by
again
8.
3 by 8. Probability of x is equal to 3 is 1 by 8. Are this sum equal to 1? Because the condition I told you, if we are claiming these numbers are PMF of the given random variable x, then it has to follow two conditions. So we can observe that all the values are greater or equal to 0. Okay. See,
Yes,
1 by
ma'am.
8, 3 by 8, 3 by 8, 1 by 8. Are the sum is equal to 1?
Yes, ma'am.
Okay.
Yeah.
So here
Doubts.
summation of I is equal to 0 to 3. Probability of x is equal to xi is equal to what will be? Probability x is equal to 0 plus. See, x0 means I can have it I also. I can take it as I. Probability of x is equal to 1. Equal to 3. Yeah. So you calculated, is it 1? One by 8 is equal to 1. Okay. Done? Anyone has doubt till now?
No, ma'am.
Okay. Can anyone tell me why this probability is 1? This is just an question. Why this probability sum of all the PMF should be equal to 1? Why it is so?
Because every event will be related to any random variable if there is a difference. Then we can
Like
say the sum of probability of every event is 1. Like this.
probability of every event is not 1. Na? Probability of event taking X, it's not
Sum
event
of
actually. Huh. Yes.
sum of
Actually.
every
Hmm.
These event probability are the fractions of whole. When we add up all, then we will definitely get one.
Yes. Your logic is correct, but your voice, I think. See, when we were calculating this probability of, like when we were calculating the PMF for x is equal to any event, x is equal to, let's say, I, and we have considered I, whatever the possible i's are, we have calculated all these probability. So when we were calculating these things, you can just observe from here, we have taken the whole sample space under consideration. See, is there any possibility, any possible outcome left when we throw, like when we toss 3 coins? These are the only possibilities, right? And we have calculated each and everything. So probability of omega is what? Probability of sample
1.
space is always 1, right?
Yes.
So here we have like, when we were calculating this is nothing but the partition of omega, but yes, we have considered the whole omega. So this is one of the reason that your sum of PMF should be equal to 1. Okay. Okay. Then, yeah, if there is any doubt in like PMF or random variable or anything,
No,
No.
ma'am.
okay, fine. If I give you one experiment, random experiment. Okay, just take the same experiment. 3 coins are tossed, okay? 3 coins are tossed. So you know the sample space and all these things. I have defined 2 random variable. X is number of heads and sorry, H maybe. And Y is number of tails. Can anyone give me one more random variable? What can you decide? What can you check for this sample space again?
When there is one head,
Two
When
heads
there is
or
one head.
will become.
See, whatever you decide, whatever you define, that should be like applicable to each and every element. If I am saying number of heads, so whenever you give me any element of that 3, like that set out of any element, let's say if you will give me t, then my X will say, okay, number of heads 0. Okay.
Yes,
So
ma'am.
just if you are giving one head, that means what Z has to calculate for this t.
Don't understand.
Understood the difference between?
No, ma'am.
yes,
Can
no.
you do it?
See, whatever you define for your random variable, that should give the output for each and every element of your sample space. So if I am saying if the random variable is number of heads, then whatever you will give to this X, it will reply some 0, 1, 2, or 3, right? When I am taking Y as a random variable, so whatever the event you will give, HTH or anything, this Y will reply something, na? Number of tails. So Y will give 2 for it, right? Okay.
Okay. And if there is, I mean, it doesn't reply anything, then it can't
It's
be
not a
a random.
function. The definition of
Yeah.
function is what? Whatever you have put in the domain, it should be defined for each and every value of the domain, right?
Yes, ma'am.
That is first condition for function. So in the starting of the class only, I told the random variable is a function, and where your domain is your sample space. So it has to reply.
Yeah.
Can we have something like, let's say, number when first head is like toss number when first head appeared. Let's take, is it a random variable? Okay. Toss number, we are tossing 3 times, na? We are tossing a coins for 3 times, okay? Or 3 coins are tossed. So when you are giving H, T, H, what should be the value of Z for this? toss number when first head appeared. When first head appeared, in which toss we got the first head? First toss only, right? Are you getting my point? So Z is equal to 1. Hello?
Yes,
Yes,
ma'am.
ma'am.
Okay. So is
Yes.
it fine? So what if someone give me the input as THH? Then what will be the Z for that?
Two.
Yes.
That is 0.
Why it is 0? Toss number when first head appeared. In this is the first toss, this is the second toss, this is the third toss. So what is the toss number when first head appeared? It is second, na?
Yes, second.
So Z is equal to 2.
It is position, I think.
Yes, position. But this is position because we are writing it like that, but it's in actually in reality, it's a experiment. So it's the first toss, second toss, third toss, right?
Okay.
Yes, ma'am.
Okay. So if someone give me TTH, then Z will be
3.
3. What if someone give TTT? Then what should be the value of Z?
0.
What does it mean by 0? See, Z is what? Toss number when first head appeared. If you say Z is equal to 0, that means on 0th toss, you got head. Is it right? Is there any 0th toss?
No, ma'am.
No. So what should be Z? Because I told you, whatever you define for a random variable, that should be defined for each and every element of your sample space. And TTT is one of the element of your sample space, right?
Yes.
So just because I am defining the function, so I will tell, okay, it's null. Because none of the toss give me the head. So Z is equal to null. So what the Z can take? What value Z can take in this case? Z can be, yes, 1, 2, 3, and null, right? Are you getting it?
Yes, ma'am.
When 1 it will be? So HTH, HHH, HHT, anything? HTT, right? These, when any element from this set come, your Z will give as a 1, right? For 2, similarly for 2 you can calculate. For 3, for none. Okay, what will be for 2?
THT, THH.
Yeah, like that. THT, THH.
Yeah.
Then what? That's all?
Yes, ma'am.
Okay. For third one, TTH.
TTH.
I guess this is the only possibility, right?
Yes,
Okay.
ma'am.
And for this TTT.
TTT.
Okay. So we will just take for PMF now. So this time I will directly put on the table. Okay. Probability of Z is equal to, let's say, Z. Okay. So Z can take value 1, 2, 3, and null. Okay. Now just calculate the probability for each and everything. What probability Z is equal to 1 will be?
4 by 8.
4 by 8. That's 1 by 2.
Plus 4 by 8.
Okay.
Second 2 by 8.
Probability of Z is equal to 2 will be?
2 by 4, 2 by 8.
1 by 4.
Yeah, 1 by
1
4.
by 4.
and probability of z is
1
equal
by
to
8.
3 will be 1 by
1
8,
by 8.
and this is
It
1
is.
by 8. So now check the properties of PMF. The first property is probability of z is equal to z for any z should be greater
Greater
than
than
or
equal
equal
to
to
0.
for all z, right? And the
Yes,
second
ma'am.
condition is summation I is equal to let's say 1 to 4, z is equal to zi should be equal to 1, right?
1.
Ma'am, I can be 0.
I can be 0. Why? If you start, it depends on, like, if you take the numbering from 0, then it will go to 0 to 3. I have written zi here because here one value is null. So here I will say my z1 is 1, z1
Because
is 2.
variable take 1, 2, 3. I think.
Yes, yes, yes. So if you take 0, then your z0 will be 1, z1 will be 2. You understood?
Okay.
It just depends on, it's an indexing only. Z4 is null. This indexing in this case is the question specific. Okay, it's not I is equal to 1 to 4. It should be 0 to infinity always. Okay.
Okay.
This is question specific. I have written. Okay. Note that this is question specific, or I should say it 0 to infinity. Let's say 0 to infinity only. Okay. Otherwise, this will confuse.
Yes.
Okay. 0 to infinity, z is equal to zi is equal to 1. So check, is it PMF correct or not? So how will you calculate? 1 by 2 plus 1 by 4.
It is correct. I think.
Yes, ma'am.
Yeah, okay. Is equal to 1. So it's done.
It is correct.
Yeah. So this trick you can use in your exam also. Like if they ask about calculate the PMF, you just calculate PMF and just check this sum. If this sum is not coming and not summing to 1, then recheck your calculation. There might be some mistake. Okay. Okay. See, if there is one probability given by, let's say x is a random variable. That takes values that takes values 0, 1, 2, and so on. Okay. This is question. I am taking one of the question. X is a random variable which is taking these values 0, 1, 2, and so on. And given that the probability of I is equal to C lambda to the power I divided by I factorial is PMF. Lambda is greater than 0. Is given here. This is PMF, okay? Is PMF of X. Then find C. Did you guys understand the question? See, P of X is a random variable which is taking the value 0, 1, 2, and so on. And P of I, this PMF of X is given at a point I is equal to C into, this is multiplier. This is not to the power. C into lambda to the power I divided by I factorial. Okay. Then we have to find C. See, here only one random variable is there. That's why they haven't mentioned. That's why I haven't mentioned Px of I. I can mention, no problem. But when there is only one random variable, so it's clear that this P of I is a PMF for this only, right?
Ma'am, please repeat. I am so confused because. Please repeat to start.
See, x is a random variable which is taking this value 0, 1, 2, and so on. And this P of I is given the PMF C into lambda to the power I factorial, where lambda is something greater than 0. Okay, then
Yes,
find C.
PMF is a function.
Sorry, P of I is?
PMF is a function.
Yes, it's a probability mass function only.
Okay. Yes. Clear.
But it will be some like, it's some abstract thing, but just, yeah, it's a function. P of I is C into lambda to the power I by F factorial. Then find the C. How can you calculate first question is, can we calculate the value of C by using only this kind of information? Is it possible?
I mean, we can try, ma'am, by using summation.
Yeah. Yes. So before going to summation, just take first easy condition that your PMF should be always greater or equal to 0. Is it here? Your P of I is equal to C into lambda to power I divided by I factorial. So the value of I they have given, it's a 0, 1, 2, and so on. So I is positive, no problem. Lambda is greater than 0, so this part is also positive, and C we have to find. So if you get C as a negative, this is not PMF, right?
Yes, ma'am.
Yes.
So
Must be greater than 0.
yeah. So now just we have to check this summation I is equal to 0 to infinity
0 to infinite.
C into lambda power I divided by I
I
factorial.
factorial
This should be equal to
will be
1.
1.
Why it should be 1? Because we have given that this is the PMF of it, X. If it is PMF, then it has to satisfy these conditions, right?
Yes, ma'am.
Yes, ma'am.
So, how will you go ahead? Do you know how to solve this series? So, C is constant here. I will keep it outside, and rest of the thing I will put summation I is equal to 0 to infinity lambda power I divided by I factorial, which is equal to 1. So this C is equal to C into, what will be this? Lambda power 0 by 0 factorial plus lambda by 1 factorial. Okay. Do you
2
know
and
anything
factorial.
like this? What is this?
Yes, ma'am. E to the power lambda.
Yes, this is nothing but the e to the power lambda. And so on. This is equal to 1, right? So this is nothing but the C into e to the power lambda is equal to 1. So what is your C then?
E to the power minus.
Yeah, which is nothing but the e power minus 1. So,
Ma'am,
yes,
how that's e to the power lambda?
that's a series, man. This is series 1 plus x plus x square by 2 factorial, and so on. This is the e power, like expansion for the e power lambda. Have you like learned this Taylor series? Hello?
No, ma'am.
Okay, maybe not. Okay. See, this e power x is a continuous function, and every continuous function has a series expansion. Okay, that means every continuous function can be written as in the form of series. Okay, so e power x is a continuous function. For this function, the series expansion is 1 plus x by 1 factorial plus x square by 2 factorial, x cube by 3 factorial, and so on. Okay, in future in mathematics, when you will learn, I don't know, in maths 2, no, When you have further studies, then you will get to know that this how to calculate this power series expansion of any continuous function. Okay. So this is actually power series expansion of e power x. So this can you relate this thing as e power lambda?
Yeah, ma'am.
Okay, fine. So c is equal to e power minus lambda. So is c positive? Anyone have a doubt on this?
No.
No,
No.
ma'am.
So e power minus lambda is positive only. Okay.
Yes, ma'am.
Okay then. Any doubt till now?
No, ma'am.
Okay,
No,
we
ma'am.
have calculated PMF. Let me give you one example. You just check whether this is a PMF or not. Okay.
Ma'am,
Yes.
are you going to give the week 9
Yes, it is week 9.
this week 9? Okay.
Ma'am, in a VAC, you write a C is negative.
Where?
So C is lambda e to the power minus lambda.
Yeah. So is it negative or positive? Exponential positive. Exponential functions are positive. Only. E power minus lambda is
Yes,
positive.
yes. It is
Okay.
1 upon e to the power lambda. Not
Yeah.
okay.
Okay. Was that the question only or anything else?
Week 2, ma'am, Qs to 5 to 8, no? Syllabus?
Sorry.
No, it is 1 to 8.
5 to 8, no?
No, 1 to 8.
1 to 8.
Yes.
Yeah. Check. Is it a PMF?
Yes, I think.
No,
Yes.
ma'am.
But I
We
think
have like
एक minute.
proper ways how to check, and you
Yes,
just
एक minute.
don't guess here.
Not looking like.
No, ma'am, it's not.
It is not because it not up to 100.
The sum
Sum
is
is
Greater than
not equal to 1.
yeah. Okay, you got it. Okay. What if this question number 1? Okay, so your px summation of p x of x is equal to what is 0.2 plus 0.15. Oh, 0.8 was there.
Yes, ma'am.
So
That's why.
it's definitely greater than. So it is like 1 plus or 3, right? It's not equal to 1. It's not PMF, right?
Yes.
Yes.
Okay. So what if this is given?
Ma'am, in week 9, only these are the things, nothing more.
Yes, there is one topic, one more topic.
Okay.
Yes, it is one more topic, cumulative.
Px of x is, let's say, yeah. Yes. Is this
It
a
is.
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes. Yes. Yes.
No, ma'am, negative.
No, ma'am.
You
It's
feel like it's negative or not?
But
We
summation
have to
is equal
sum.
to 1.
We have to sum all of
Ma'am,
that.
the sum is equal to 1, ma'am.
Yes.
But
Yes.
negative
every
it should not be
event also
negative.
greater than 0.
yes. Whenever
Yeah.
you whenever we check for the PMF, there are two conditions. The first condition is Px of x should be greater or equal to 0 for every x belonging to capital X, right? For every x. See, for x is
Okay.
equal to 0, this is negative. I said you will
Yes.
say no when I was writing the question. Okay, see. And the second condition is summation of Px of x should be equal to 1. Okay. So this is like common practice. We check the sum directly, but remember this first condition also, that because you know what is this px of x is? What px of x is? It is equal to, yes, probability of capital X is equal to x. And here it is given that probability px of 0 is equal to minus 0.2. Can probability be negative?
No.
No, right?
No, ma'am.
No.
So that's why this first condition comes from there, that probability can't be negative, right? Okay. I hope till this everything is clear now.
Yes, ma'am. Yes.
Yes,
No
ma'am.
problem.
Okay. Then there is a topic called as cumulative distribution function.
Previous one is probability mass function.
Yeah. So generally we write it as a CDF. Someone has asked me in between that, is PDF and PMF is same?
Yes, ma'am.
Yes. Is that person here? Okay, you are the one.
Yes, ma'am.
See, we have random variables can be may be a discrete random variable and a continuous random variable. Okay.
Okay.
Discrete and continuous. So when it comes to discrete random variable, we say it as a PMF. Okay.
Okay.
We say the things, whatever we calculate, we call it as a PMF. What is this PMF? The probability of each and every event. Okay.
Yes, ma'am.
And the same thing we will be doing in continuous random variable. At that time, we will tell it as a PDF, probability distribution function. Okay.
Okay.
So
So whenever there is a probability distribution, there that will be continuous random variable.
Random variable, yes. What we calculate, like calculation is like somewhat different there. But what we calculate the probability of event only. Okay. So yes, CDF. Till now, what we have. Sorry, please mute your mic.
Ma'am,
Yes,
what is the long form of PMF?
probability mass function.
Okay.
We are discussing this only till now.
Actually, I was joined just now, just 5 minutes back.
Okay. Fine. So, what we have calculated till now, probability of capital X is equal to small x, the probability of individual event. Okay. Now, we can calculate probability of x less or equal to x. What does it mean by that? When you want to calculate all the probability of all the events that happened before this x. Okay. And let's say we have tossed 3 coins. Okay. So 3 coins are tossed. And X is a random variable. It's calculating number of heads. So what if someone wants to calculate the probability that number of heads should be at least 2? Sorry, at most 2. For at least 2, the equation will change, right? Hello?
Yes, okay, ma'am.
Yeah. So this X less or equal to 2 indicates what? Number of heads can be
At
0,
most
1
2.
or 2. At most 2.
2, yes.
Okay. So this kind of things we do in cumulative distribution function. It is
So
denoted by this.
zero,
Yes.
can we take 0 heads like till 10?
Sorry, 0.
0 heads for
X
this
equal to
lesser
0.
than.
Yes.
Yeah, you can.
When it's given that probability and number of heads are at most 2, that means 0 is also there. See, so this kind of situation may come when you have to calculate this kind of things. So your probability X is equal to 1, X is equal to 2. This is simple question, so you can calculate one by one. But what if there is one function which will easily give you this kind of things, right? So this is what CDF's cumulative distribution function. It is denoted by capital F generally, and it is expressed as f of a is equal to probability of x less or equal to a. So I wrote that probability of x less or equal to 2, okay, is equal to question mark. So in terms of CDF, they will ask you calculate f of 2 is equal to what? Okay. So can you give me what will be the f of 2? As 3 coins are tossed and number of x is the number of heads. X is a discrete random variable. So what will be the f of 2 here?
V by 8.
We can say P of X equal to 0, plus P of X equal to 1,
Yeah.
plus P of X equal to 2.
Yes, all are added.
Generally, CDF is what? If your X is a random variable and is taking the value x1, x2 and xn, such that these x1s are such that x1 is less than x2 and x2 is less than x3 and so on, xn, then f of x2, that means f of xi will be equal to probability of capital X less or equal to xi. What does it mean by it? That means f of xi is nothing but the probability of x1 plus probability of x2 and so on till probability of x is equal to xi. That means if they are asking you about the like CDF of any xi is nothing but the sum of all the events that happened before it. Okay, if we have to calculate the CDF of x3, then we have to sum up all these x1, x2 and probability of x1, x2 and x3. Okay, this is nothing but the CDF. So when it comes to this f of 2, at that time you should have knowledge of what your x is. Your x is a random variable which is taking number of heads and it can take values 0, 1, 2 and 3, right? So what will be the f of 2? See, this is your x1, x2, x3, x4, okay? and it's asking for CDF of 2. So whenever you calculate f of 2, you have to sum the probability of x is equal to 2, x is equal to 1, and x is equal to 0. Whatever the number behind a 2 is. Okay. So generally we can do it like just mark your numbers on a real line. It is 0, 1, and 2, and 3. So we are asking for the CDF here, na? So calculate the probability before all this. Okay. So what is it? P of x is equal to 2 plus probability x is equal to 1, probability of x is equal to 0. Okay.
Yes, ma'am. Okay.
Okay. So what is the sum then? It should be, I guess, 7 by 8. See, when x is equal to 3, x is equal to 3 can take, when it is possible, x is equal to 3. This is number of heads, right? 3 heads can take only once in a time, right? So 1 minus 1 by 8, it's 7 by 8. Or you can go by x is equal to 2 also. See, what is probability of x is equal to 2? When 2 will come, h, h, t, t, h, h, and t, h, t, right? So it will be 3 by 8. And
I think for 1 by 2, I think.
What 1 by 2?
Previous one.
Plus probability of
Ma'am,
x
you
is,
have written pH.
oh, sorry.
Yes, ma'am.
HTH, yeah. Sorry. Okay. Probability of x is equal to 1. When it will come? HTT, THT, and THH. Again 3 by 2. 3 by 8, sorry. And probability x is equal to 0 means? Yes.
1 by 8.
1 by 8. That's TTT. So this is nothing but the 7 by 8. Okay. You got the idea how to calculate CDF?
Now you done
And for
earlier,
one
ma'am,
head,
like 1 by 8 1 minus 1 by 8.
Sorry.
How you done it earlier, like 1 minus 1 by 8.
See, that's what. When x is a random variable and you know your x can take value 0, 1, 2, and 3. What x is? X is number of heads, right?
Yeah.
So, and we are calculating f of 2. F of 2 means your number of head can be at most 2. So your number of heads can be 0, number of heads can be 1, number of heads can be 2, but number of heads cannot be 3. Okay. You have to calculate the probability for all these 3. One thing we know that the probability, the sum of all these probability is 1. And probability of getting x is equal to 3. That is number of heads is equal to 3. When it comes, it will come when the event HHH will happen. And what is probability of this HHH? Its probability is 1 by 8. So just
1 by
subtract it.
8.
So it is 1 minus 1 by 8. 7 by 8.
It's
See.
more simpler way.
Yeah. See, whenever f of 2, f of x, what is f of x? It is probability of x less or equal to x. Okay. So, if I ask you, calculate p of x greater than 2, how will you calculate? Okay. The question is,
X is greater than 2.
3 coins are tossed and x is a random variable such that a capital X is equal to number of heads. Then fine, then calculate P of x greater than 2. Yeah, how will you approach this question? you have one idea that f of x is equal to probability of x less or equal to x. And you know what does it mean by probability of x greater than 2? Sorry, x greater than 2 only. It's not there. Huh?
Probability of x is equal to 3.
Sorry.
Probability of x is equal to 3.
Yeah.
It can be
So
3.
yeah, the number of heads. This is nothing but the probability that number of heads more than
Yes.
2.
Yes.
It means at least 3, right?
More than 2, yeah, at least 3.
Oh,
Yes, because but 3 coin is tossing, then only one possible.
Yeah. So probability of number heads more than 3 is what?
1
This
by
is
8.
nothing but the probability of
1
x
by
is
8.
equal to 3. Yeah, 1 by 8. Okay. This is what I have shown you the question formation using this CDF. Okay. You
Yes.
got the meaning of CDF? Sorry.
Yeah, ma'am, we got.
But
Okay, okay, just a minute. Okay. So using this PMF and CDF, we can have the graph also. Okay, this is the last topic of this week. So if there is one example in which you can have both the things in very clear, clear way, you will get how to have a graph. Okay. The okay. The example is the first one only. Let's say you have thrown 2 dice. Okay. 2 dice. Okay. Then what is your omega that you know? Okay. There will be some 36 outcomes are there. Okay. Till 6,6. Fine. And
yes.
x is sum of numbers. Fine. So we have to calculate PMF and then CDF, and then how to draw the graph for the same. So let's start with the PMF. Okay. So what the values x can take?
X can take 1.
2 to 12.
How? When it will take
2
1?
to 12.
Yes, 2 to 12 is fine. When it will take 1?
When we add 1 plus 1.
1 plus 1 is 1. Is it so?
No, it is 1 plus 1 is 2. Only
It is
one
not
case
there.
of 36.
So when we throw a 2 dice, then there is no possibility of getting 1.
Yes.
Okay, the sum of 2 dice only. Okay, px of x. So yeah, when x can take the values 2, 3, 4 till 12. So what is the probability for x is equal to 2?
Is
1 by
One.
1 by
36.
yes.
Okay, sorry.
1 by
Okay,
36 for
just
2.
don't
1 by
simplify
36.
it. Like it's my suggestion, don't simplify it because we have to draw the graph. So it would be better if every number has same denominator. So it will be 3 by 36, right? 1 by 12 you are saying.
How 3 by 36, ma'am?
No, ma'am. 1 by
Yes,
36.
it is 1 by 36.
Sorry,
One comma.
sorry. It should be 1 by 36 only, no? Sorry.
Yes,
Yeah, 1 by 36.
yes,
Sorry.
yes.
Yeah. What will the probability of 3?
2 by
1.
2
30.
by 36.
Okay. 2 by 36. Then for 4,
3 by 36.
Yes.
yes, 2, 2, 3, 1, 1, 3. Okay. 3 by 36. For 5,
4 by 30.
4 by 36.
4 by 36. For 6, 2, 4, 4, 2,
5 by 36.
5 by 36. Yeah.
7 is 4 by 30.
7 is
No, no, no.
6, 1, 5, 2, 2, 5, 4, 3, 3, 4, 1, 6 also. 6 by 36. Okay. Then what? 8, 9, 10, 11, 12.
5 by 36 and 4 by 36. 3 by
Yeah,
36.
it will be decreasing now. 5 by 36, 4 by
Yes.
36, 3 by 36, 2 by
2 by
36,
30.
and 1 by 36. Okay. How I know? I will say you. How do I know these things? Okay. After this graphical thing, you will also get this thing. Okay. See, have a graph of this. If we want to plot this, sorry, just a minute. Yeah, we want to plot this, plot a graph for this. So, how will be your graph? In x-axis. Just a minute. Fine. This will be px of x. What are the values for px of x? Is 1 by 36, 2 by 36, 3 by 36. Okay. That was the plus point. I avoided to simplify the numbers. Okay. Okay. This will be values on x. So yeah, what are the values now? Some 2, 3, 4,
4, 5, 6 till 12.
till 12 we have, right? 7. Px of x, let's say here is somewhere it is 1 by 36.
2 by 36. 3 by 36.
Yeah, like that.
4 by 36. 5 and 6.
36, fine. Okay.
Yes.
So for 2, what was the probability? It was, okay, 1 by 36. So here some bar is like that. For 3, it was 2 by 36. For 4, it was 3 by 36. See, it was increasing till 7, no? 5, 6, 7. Till 7, it was 7 was the highest. This is 3. Then
4,
Sorry, this adjust
It
this.
is good. Why?
These are straight on. In 5, it will be like this. Done. Okay. So can you see one pattern? Like these are all like poles only. I'm not able to make it straight.
Only one line can. Is pretty good.
Let's see. So can you see one? Can you observe one thing here?
Yes, ma'am.
What's that? There is some distribution is there. Like that's why we call it
First,
distribution. And when you progress in the course, you will get that maximum of the time we need this kind of distribution only, which is symmetric about something. Okay.
yes,
See, at x is equal to 7. And if you check, 7 is the middle point of whatever the x can take the values. 2, 3, 4, 5, 6. There are 5 values on the left, 5 values on the right, and 7 is the big one. This kind of distribution is very easy to study. See, like this kind of things we will do in future. But now it's just a distribution of PMF. Okay. Sometimes this distribution is symmetric. Sometimes you will get a different kind of graphs for the different probabilities. Okay. So this was the graph for PMF. Same we can have for CDF. Okay. For CDF, how will we calculate? So yeah, we have all these probabilities calculated. Is my network issue or
what
what?
is this?
It might be network issue. Sorry. Just a minute. You have to wait. It will load again. Huh? Yeah. So CDF, how will you calculate? For CDF, you need, this is your f of A. Just by general observation, can you just guess what should be the highest value of f of A? Just a
Highest
general
value of
observation.
all the sum of probability. PMF.
Yeah, this is okay, but you can have a precise value for f of A. You can guess, you can have how. Just let me again describe the CDF. Yes. Yeah.
One.
Yes. It can be 1 at max. So whenever we calculate f of A, that means we are calculating all the probabilities that is less or equal to A. So when the same thing, what our x is what? Sum of all the sum of the numbers, right? Our x is highest x is 12. The value
Yes.
highest A it can take is 12. So when you will calculate f of 12, it will sum all the previous ones. So that will be, sorry, this is the f of 2. F of 12 will be 1, right? So
Yes.
now we want f of 1, f of 2 and everything. So what is f of 2 here? F of 1 in the same case. The question is same only. Yeah. What will be the f of 1?
One by 30.
F of 1 by 36. Why? What is f of 1 by the way? F of 1 is
0, ma'am.
yes, it is 0 only. Why it is 0? Because f of 1 is probability of x less or equal to 1. So can
okay.
x take values less than 1? Not even 1 it can take, right? So
Yes.
yeah. So we can have f of A is like that also. Like f of A is equal to, we define it like this. When the value of A is 1, let first calculate f of 2. F of 2 will be
1 by 36.
1 by 36. So your f of 1 was 0. That means
F of 2, no. Yes. Because f of 1 is 0. 1 by 36 plus 0.
so your f of A was taking the value of 0 till your values of A were less or equal to 2, right? Sorry, not less or equal to, strictly less than 2. And it became 1 by 36 when the value of A was
Less than 3.
Less than equal to 2.
Less than 3 only.
Less than
Okay.
3 because pattern.
Just calculate f of 3 then. As soon as you calculate the f of 3, you will get the range for A.
2 by 36.
2 by 36.
Yeah. So what is the range for, okay, this is 2 by 36 when A is equal to 3. Okay. But what should be here?
Equal to.
Equal to. What is then f of, see, in CDF you can have f of 2.5 also, na?
Okay.
Someone can ask you what is f of 2.5. So f of 2.5 is nothing but the probability of x less or equal to 2.5. See, f of 2.5 will be equal to probability of x less or equal to 2.5. Okay, you don't have 2.5, but you can have x is equal to 2 plus probability x is equal to 1 and so on. Okay. So what's your probability of x is equal to 2 here? It's 1 by 36. So we'll say, okay, my probability of 2.5, f of 2.5 is 1 by 36. So this f of A will take 1 by 36 till your A value will be greater or equal to 2 and strictly less than 3. Similarly, when the value becomes 3, your f of A will take the value 2 by 36, okay? Until 4. Okay, what is f of 4 then? Are you getting my point?
Could you
Yes,
explain for
Yes.
F or 4?
Sorry, f of 4, what is f of 4? By the way, I think you guys have done one mistake. When I asked you f of 3, what should be the f of 3?
Yes, ma'am.
No, it's
3 by
3 by
36.
36, no?
It should be 3 by 36 because we have to sum all the previous things.
Yes, ma'am.
Yeah, what is then next?
Ma'am, for F of 3, we have to calculate the probability for 2 and 1 now.
Yes, 2, like 2 and 1 if it is there, but 1 is not there, so f of 2 plus f of 3 only. It means, sorry, probability at x is equal to 2, probability at x is equal to 3 only. Okay,
Will be greater than equal to 4 and less than 5.
sorry. For f of 3, the probability will be x is equal to 3 plus probability of x is equal to 2. Yeah. Okay.
What, ma'am? In this case, A will be less than or equal to 3, no?
Less than
If
or
we,
equal to 3. Sorry.
in this case, 3 by 36.
Huh.
Because all of sum f of 1, 2, and 3, then A will be less than or equal to 3, at most 3. What?
For which you are saying this 3 less or equal to A less than 4. This
Yes,
one.
yes,
Okay.
ma'am.
the value of f of a will not change till you calculate f of 4. Why? Because in between 3 and 4, there is nothing in between 3 and 4, there is no value that your dice, the sum can take. Your sum can take either 2, 3, 4, 5. So when you will calculate the middle values between 3 and 4, the sum will be same. F of 3, probability at x is equal to 3 and x is equal to 2. Okay?
Okay.
See, we will check in the graph.
No, ma'am. It is in the formula, right? Is f of a is equal to p of
X less or equal to 3,
yes,
less or
yes,
equal
ma'am.
to 4. Yeah.
Then we use till 4 at most 4.
Yeah, when we use at most 4, that's why I haven't written equal to 4 here. See, here it's strictly
Yes,
less than
but
sign is there.
it is also greater than 3 now.
Yeah, it's greater than 3, but just calculate. I have asked this, see this. If someone will ask you, find the f of 3.5, which is, let's take f of 3.8. How will you calculate it? It's greater than 3, right?
Yes.
So how will you calculate it? It is nothing but the probability x less or equal to 3.8, right? So you will check your values of x. Your values of x can take 2, 3, 4, 5, and so on. So this is for you.
Okay.
What will be this? X is equal to 3 plus probability of x is equal to 2. Rest you know that is 0. So you will just calculate this one. Probability of x is equal to 3, you know that is 2 by 36. Here you know it is 1 by 36.
Okay, and that please check me and confirm it. 3 is less than or equal to a is less than equal to 4 is equal to a less than or equal to 3. It
What
can
you
be
say?
right.
Can you repeat? I will just
That
write and get. Yeah. What? Just repeat what you have said.
the third point is this is right written as 3 is less than a is less than 4.
Not less than, less or equal to 4, 3.
Less than a is greater than or equal to 4 and a is less than
Less than
4.
4. Yes.
It can be written as a is a is less than or equal to 3.
Less or equal to 3. Why? It's greater than 3 now. It's greater than 3, then why I will write it less or equal to 3? The range of A is lying between 3 and 4. Are you getting?
Yes. I'm
Okay.
confused. Okay.
Let me have a new page if possible. Yeah. See. F of 3.8 you got, right? See.
Yes, ma'am. I understand. No problem.
Arey?
I got it.
Okay, just a minute. It's some network issues there, so I am not able to write. Okay, have you guys calculated f of 4, f of 5?
Yes.
We have to
No
just the
problem.
previous numbers, and we will show the plot. Okay. Just give me a second. Huh? Just calculate f of 4. What is the f of 4? Anyone?
Ten by 36.
Yeah. Okay, then. Yeah. Sorry. What is, I have to written all this thing again. F of A we are calculating. F of A we are calculating. So when the value of f of A will be 0, when the values of A will be less or equal to 1, right?
Yes.
or we can say more precisely, this is not less or equal to 1. This is A is strictly less than 2. As soon as A becomes 2, as soon as A becomes 2 or greater than 2, your f of 2 will take the value, what?
1 by 36.
Right? We have calculated this. Then 2, until what point this will take 1 by 36? Still we do not get to 3, right?
Yeah.
The point we will reach to 3, this will increase to 1 by 36 plus 2 by 36, that is 3 by 36. Okay, so this is strictly less than 3. Okay. Then, now this 3 by 36 will be the value of f of A. Till what time? As soon as, yes.
C
Till
less
4.
than
Less
or
than
equal
4.
to A less than 4.
See, whenever you write 3 and this sign is there, this is less or equal to A, right?
Yes.
Just don't say it A is less or equal to 3. A is not less or equal to. A is greater or equal to 3 here.
Yes,
Okay.
3 is less than or equal to A.
Yeah. Okay.
Okay.
So till what point this value will be 3 by 36?
4.
A
Till
is
the
less
point
than 4.
Less than 4.
A is less than 4. Fine. So what will be, as soon as you reach to 4, what will happen?
10 by 36.
Yeah, 3
No,
into 2 was there, na? See,
Yes,
I
yes.
remember that 1, 2, 3, like that what was. So 3 by 36 plus 3 by 36. This will be 6 by 36.
6 by 36.
What will be the range?
A is greater than or equal to 4 and less than 5.
5. Okay. Okay. Then what will be the next?
Is 10 by
Will be
36.
10 by 36 when your A
Is
will lie between 5 to 6. Okay. Okay, it's going long, huh? Okay. Then what next?
12 by 36.
10, we add 5 now, 15 by 36.
Oh.
Yes, ma'am.
From 6 to 7.
7.
Why it is 15 by 67, 36 you got? See,
Yes, yes.
your F3 was, F5 was 10 by 36. And you
And
are
F
adding F6 means probability of X is equal to 6, which was some 5 by 36, right? So yeah, next one will be 21 by 36. Why it is 21?
add for
8. Okay. Then next 21 plus
6.
See,
5.
for 7 it was 6 now. So
Right.
now it will be 5, 5, right? 26,
no,
right?
Are you already done?
no.
Just give me the
F3.
probability of X is equal to 8. Probability of X is equal to 8. What was it?
Is
5, 3, 3, 5,
7.
4, 4,
4, 4,
2, 6, 6, 2.
2, 6, 6, 2.
How
Anything else?
come, ma'am, how come it's 4, 4? Because it should be less than 8, right?
No. I'm just calculating probability X is equal to 8.
Not a CDF.
Yeah,
Okay,
I'm just
8.
because see, I have to calculate the CDF for I have to calculate f of 8. Okay, and I know the value of f of 7.
Okay.
So how will I calculate it? I can calculate it just adding probability of X is equal to 8, right? See,
Okay.
what will be f of 8? F of 8 will be the probability X less or equal to 8. That means whatever the value your X will take, all the values, just take the probabilities of all the values X can take before 8 and 8 also. So 8, 7, 6, 5, 4, 3, 2. Okay. So this I know probability X less or equal to 7, that is f of 7 I have already calculated, that is 21 by
Yeah.
36.
Yeah.
So now I need only probability x is equal to 8. So I have calculated here, it is probability of x is equal to 8. So it is 26 by 36. Okay. This one was 21 by 36. And I got 5 by 36. Okay. It was good way
yes.
na, to calculate
Yes. Yes.
sometimes. Okay. Yeah. So this will be 8 less or equal to a less than 9. Yeah. Next. Now you have to calculate for 9.
30 by
30.
36.
4, 5, 5, 4.
30 by 36, right? Then
33 by 36.
33 by 30.
this I have to.
And
Yes.
35 by
36.
36. 35 by 36.
See, this is not way to write the bracket. Let me check if there is an option. Okay. Yeah. Yeah, 10 less or equal to a less or equal to less than 11. And when it will be 11, it will be 35, right? 35
Yes.
by 36. And then 1. 11
Yes.
less or equal to a less than 12. Now, what should I write? A
A
Is
equal to
equal
12.
to, yes.
Less than equal to 12.
less than
Less
equal to
than
12.
equal to.
What if I ask you the probability f of 13? What if I ask to calculate f of 13? How will you calculate it?
Oh,
It is 0.
0.
How? Just calculate it. Just don't guess it. What is the f of 13? This is equal to probability of what?
13.
Not 13, man. This is CDF.
Means
Yes, yes, yes.
This is CDF. So probability of x less or equal to 13. When you
Yes.
calculate probability x less or equal to 13, what does it mean? You have to calculate all the probabilities of
Till 12.
x. Yeah.
12
Probability
plus
x is equal to 13 plus 12 plus, sorry, x is equal to 12 plus till what?
ze-
2.
0 or 2. 2 is
0.
my minimum point. Why I will take
Yes.
0 and all these values, right? What is probability of x is equal to 13?
1.
0.
Who told
0.
1?
Null event.
Yeah. When 13 will come, probability of x is equal to 13 means when you
0.
throw
Yes,
2
ma'am.
dice, what is the condition? That sum will be 13. There is no condition, right?
Yes.
So this x is equal to 13 will be 0.
0.
At this probability x is equal to 12 and on, so on. I will just take it as probability x less or equal to 12. I will
Ma'am,
sum up
total
it,
is
right?
1.
Huh?
Total is 1.
Total is 1. So that's why when it came to 1, I wrote it a greater or equal to 12. So whenever my a is greater than or equal to 12, I will take it as a 1. Fine?
And we
Yes.
can also write in opposite way, a is less than equal to 12.
A is less or equal to 12. See, a less or equal to 12. If you write like this, what does it mean? Is your f of 11, is it less or equal to 10, right? 11 is less
Yes.
than 12. What is f of
Yes.
11? It's not 1.
Yes.
What is f of 11? It was some 35 by 36, right? We have calculated it. Right?
In this case,
Yes.
we add 2 times all things.
But we are adding f of L 12 also, no? Because
Sorry?
A is less or equal to 12.
Yeah.
What
So,
12 is?
yeah, what is the question? Sorry.
I mean to say A is less or equal to 12. That's why f of 11 plus f of 12, we should add both.
No. See, whenever there is written a less or equal to 12, this means either a is strictly less than 12 or
Okay.
a is equal to 12.
Equal to 12. Right.
Okay, fine. So
Yeah.
when I
Or
am
means
taking f of 11,
hmm,
f of 11, that means you can take the 11. Why you take the 11? Because a is less than 12, right? Your a is 11 and 11 is strictly less than 12, right? Okay. So by formula, f of 11 will be what? Probability of x less or equal to 11, right?
right.
And when we say probability x less or equal to 11, that means this is nothing but the sum of probability x is equal to 11 plus 10 plus and so on, right?
Yeah.
So what will be the value at that time?
35 by 36.
So that's why here, here we can't say a less or equal to 12. We have to written whenever a is greater than 12, the CDF of this function will be 1. Okay.
But what I mean to say that f of 11 plus f of 12.
F of
Can't we-
11 plus f of 12, what does it, what is this by the way?
F of 11 is 35 by 36 plus 1 by 36.
F of
It
12
is
is CDF of f, that is 1.
oh, okay. Okay.
See.
Ma'am,
Got it.
Some-
Got it. Got it. Ma'am.
ma'am, you've written A is less than 12. So for the F value,
I have
CDF, we have to
written
take.
a greater or equal to 12.
No, ma'am, can you scroll up the slide? Yeah, ma'am, here.
This one someone was asking, that's why I asked. And this
No, ma'am,
was
we have to take like it's given A is less than or equal to 12.
yeah.
So for the F value inside the bracket, we have to take always one value less than it, like 12, so 11.
No, you can take pointer value also. You can take pointer value also, but you do not have anything to say. Someone can ask you like f of 11.3, calculate f of 11.3 for this question. How will you calculate? This will be the probability of x less or equal to 11.3. How you will calculate? You don't know this 11.3, so you will start with 11, 11, 11, 10, 9, and so on. So that's why this value will give you 35 by 36 only. As soon as you reach to 12, you have the probability for f, you have the probability for x is equal to 12. So your values get changed. Okay. Your value will not change till your x will reach to will not reach by plus 1 number.
Ma'am,
Yeah.
ma'am, doubt. Ma'am,
Yes,
so random variable, right?
Yeah.
Is it necessary that the random variables are supposed to be like consecutive numbers? Say, for example, the random variables are 0, 1, and we
Yeah.
skip 2 and 3, and it's 4, 5, 6.
Yeah, it may be
Right?
possible. Yes.
Okay. So then for each of the random variables, we'll get like probabilities, right?
Yeah.
So now, say the random variables given are 0 and 2, 3 are the random variables. So 0, 2, 3, 4. So if we are asked to find, the f of 2, what we have to do is the p of x equal to 2 and the p of x equal to the previous number, right?
Yes.
Previous random variable, right? So we'd go to 0, right?
Yeah.
Because there's no previous other random variable.
Yes.
Am I right?
Yes.
Okay.
Okay. See, this is 1 by, like I'm just assuming this because we have to go to till 36 by 36. Okay. So all these are number. This is 35 by 36 and so on. Okay. Can you, are you able to read this number, what I have written on this f
Yes,
of
ma'am.
a side?
Yes, ma'am.
Okay. So it will be like that. Okay, these are values like that, 1 by 36, 2 by 36, till 36 by 36. Okay. So I hope now you will get clear cut view from this figure. See, what is your, this is your f of a value, this is your a value, right? Okay. This x-axis is your a values. What your x is taking? X is a random variable which is giving you sum of the numbers that is shown on the die. Okay. So let's start. When your x will take x is equal to 0. Okay. Let's say x is equal to 0 or 1. What is your f of a? Your f of a will be 0 only. Why it is 0? Because there was no event so that your x can take a value 1, right? What is x? X is the sum of the numbers that is shown on the die when two dice are thrown. So when you throw two dice, x can't take value 1. Okay. But we can have the probability for x is equal to 1. That probability will be 0, right? Similarly, when we come to x is equal to 2, what was the probability when x was equal to 2?
1 by 36.
1 by 36. Okay, here 1 by 36 is there. So this dark line is for 0. Your probability was 0 till this. When x become 2, your probability became 1 by 36. Okay. Now observe that this is CDF. Okay. So when you come to calculate f of 3, what will be the value of your f of 3? Yeah, they have calculated it. Have you noticed? Anyone have noted?
2 by 30.
It will be 3 by 36.
Yes, yes.
We are calculating f of 3, man. Okay. So here somewhere it will be 3 by 36. So let's say 3 by 36. Okay. Sorry. Okay. So when 3 comes, it will be f of 3. But what, when the value will be lying between 2 to 3, can your f of a will change at that moment? No. Your f of a value will lie here only. Where?
Repeat, ma'am.
Yes.
Repeat this step.
Yeah, see. When you will calculate f of 2, your value will be 1 by 36. When you calculate f of 3, value will be 3 by 36. But when you will calculate the CDF in between 2 and 3, there are uncountable numbers, right? 2.1, 2.2 and so on. You will calculate that number, you will get the same value of f of a, which is equal to f of 2 only, right? So f of till, that's why we have written that this value. See, f of like f will take 3 by 36, sorry, 1 by 36 till the value a lies between 2 and 3. As soon as it becomes 3, it becomes 3 by 36.
In this interval, 2 to 3.
Yeah. In the interval 2 to 3, the value will be 2 by 30. 1 by 36.
Yes.
Okay. And in the interval 3 to 4, it will be?
It is 3 by 36.
3 by 36. Then it comes to 4. And when it comes to 4, it will take some 6 by
6 by
36.
36.
Okay, let's assume somewhere it is 3 by 36. Okay. Then when it comes to 5, it will go to what
10
number?
by 36.
Okay, 10 by 36. Then it will stay to 10 by 36 till 5 to 6. But when it reaches to 6, it will become
15 by 36.
Yeah. I'm just randomly pointing out because it will be very difficult to point these points, right?
Yes, no problem.
Yeah. So just consider it. Okay. Similarly, so my point is to show you that this function will be keep increasing. Okay. This 7 to 8, it will be somewhere here. It was some 21, no? 21 by 36.
Yes, yes, yes.
Then what for 8?
It is 25 by 36.
Let's say here 8 to 9, then 9 to 10,
It is
then 11, 10 to 11, right?
yes,
And what was for 11? F of 11 was 35 by 36 something, right?
yes, yes. And 12 for 1.
For
One.
12, it was 1.
35, 36.
Now just change, now just give me, till what value this will take 1?
Till infinity. Means,
Yes.
Yes.
That's why I was saying that, what I was saying, that f of a
12.
will be equal to 1 for all a greater or equal to 12.
12.
You understood why it was equal to 1 for greater or equal to 12?
Yes,
Yes.
12 to infinity interval, it is 30 by
Right?
36.
So similarly, if someone will ask you, okay, you can give me f of a is equal to 1 for a greater or equal to 12. Can you just give me when f of a is equal to 0 for all the values of a? What should be the values of a so that your f of a will give you 0?
Less than 2.
Yeah. So finally, yeah. Yes. Whenever it will be less than 2, your f of a will take 0. Fine. You understood this concept?
Yes, ma'am.
Got it, ma'am.
Yeah. So this is kind of step function. Why it was step function here? Because we have considered x as a discrete random variable. When you will study x as a continuous random variable, you will get some nice graph. Okay, that will be continuous. Okay. Then if anyone has any doubt, then please tell me. Otherwise, yeah, all the concepts are covered of this week.
No, no.
Okay, then see you soon.
Ma'am,
Yes.
I want to take a screenshot of this all summary. Please zoom out.
I guess we have all these okay, of these things.
All can you must zoom out and take.
See, you can have this lecture on YouTube now.
Yes.
And YouTube, and I think on your portal also it will be available. So you can take from there.
Okay, okay.
Or
No.
I will share the file. That will be easy for you.
Yes, yes, you can share file.
Just
Please
take care
share.
of this thing. This is not a mathematical notation. We can't write like that. This was my bad. Like we should write it as like this only. This is curly bracket. This is just a notation. That's not there is nothing wrong. Just it
Okay.
was long enough, so there was a issue. Yeah. So I hope you understood the concept. That's more important.
Yes, I understand.
Okay. Okay then.
Thank you, ma'am.
Thank you. Hello.
Hello, ma'am.
Someone was asking for quiz 2 syllabus.
Yes, ma'am, please.
Yeah, quiz 2 syllabus is from week 1 to week 8, and majority part will be from week 5 to 8.
Ma'am, I have a question in extra activities in section 2, in which we have to elaborate the data, categorical and numerical. I have a request to kindly one demo class on this.
On which topic, sorry?
एक्स्ट्रा एक्टिविटी मैम, जो एक्स्ट्रा एक्टिविटी है उसमें कैसे डेटा को असेंबल करना है एंड कैसे उसको रिप्रेजेंट करना है, तो उसके लिए एक रिक्वेस्ट है कि एक डेमो क्लास फर्स्ट में हो जाए, तो कैसे हम लोग उस प्रोजेक्ट पे काम करें जो एक्स्ट्रा एक्टिविटी है.
Okay, okay, okay. Okay, I will
Because I have
convey.
collected data from other side, but how to organize this data and how to represent whatever is question is asked in activity.
Okay, fine. We will have one session on that.
Can you, ma'am, please verbally can advise for extra activities how to differentiate in question asked to differentiate categorical data and numerical data and scale measurement?
Sorry, what is the question there? I don't know actually.
मैम एक्स्ट्रा एक्टिविटी में जो सेकंड एक्टिविटी है उसमें है ना, हमको जो डेटा हम किसी भी लिंक साइट से हम लोग
Yes, I know that. हाँ.
हाँ, फिर इसके बाद उसमें हम लोगों को बोला गया है कि आप इस डेटा को ऑर्गेनाइज्ड करिए, उसमें हमें बताइए कि क्या कैटेगोरिकल है, न्यूमेरिकल है,
Yes.
और इसके
हाँ.
बाद उसमें उस फ्लो पाई चार्ट या जो भी डायग्राम है उस पर रिप्रेजेंट करिए ये डेटा क्या बताना चाह रहा है। तो मेरी रिक्वेस्ट है कि एक ऐसी क्लास हो जाए जिसमें मतलब हम लोगों को थोड़ा डेमो मिल जाए कि हम लोगों को किस
For
तरीके
that, we have a tutorial session on week 1, week 2, I guess. Yeah, there is a video lectures
बीच
for
में,
that
सॉरी
also.
मैम, बीच में
In week 2, I guess. In
week
week
2
1 or week 2, there is a one session, one video is there in which we have created the pie chart and all these things on Google Sheet.
हाँ हाँ या मैम,
So
okay.
just go and look out there. If still there is a problem, then yeah, I will tell to have a class on that.
Okay ma'am, okay ma'am.
Okay,
Thank
you just look out that. If there is a doubt, then please ask on the next session. Then we will sort it out. Okay.
Okay ma'am, okay.
Yeah, there is a session.
या मैम उस जो सेशन है उसमें मैडम ने बताया कि कैसे गूगल स्प्रेडशीट बनाना है, उसमें डेटा जो है वो लिमिटेड है, इसमें बोला हुआ मिनिमम 1000 रो लेनी है।
Yeah, the concept will be same only.
ओके मैम,
Okay.
थैंक यू मैम।
Yeah, thank you.